start doing the introduction. My name is DJ Van Hooyer, better known to many as working hard in IT. Whether that's true or not, I leave up to the viewer or listener. We're going to be talking about failover clustering and Hyper-V enhancements in regards to high availability. And the first few slides I have to skip over quickly anyway. And it's about troubleshooting. There's two really nice enhancements in troubleshooting. It's something we don't like to do most of the time, but we need to do it. One is that the cluster log commandment, to get all the information you need when you're in trouble in Microsoft, is vastly improved. It's a lot more readable. It can be parsed with your favorite CSV reading tool. It contains all the information about what time zone the nodes are on, and it collects everything in one big swoop, so you can send it off to Microsoft or whoever supports you. And instead of the game of send me these logs, send me this information, they've tried to get all that relevant information in one big gathering command, and basically you're golden. And the other very nice improvement that we've seen is the fact that we now have a new way of creating a memory dump. And that new way is actually just grabbing the memory that the parent partition is using. Which means that if you have a Hyper-V host with half a terabyte of memory, and that blue screens, you can get the memory dump that's only relevant to the parent partition, which is kind of nice. It's a lot smaller, anything between 6 to 15 gigabytes, depending on all the crap you've got running on that host, antivirus, backup software, whatever, versus half a terabyte of size. Loading it up to Microsoft, copying that around, or basically even creating it is an issue. Because who has half a terabyte of free disk space on his Hyper-V host, just in case you need to make a memory dump? Well, basically you don't. So that's a nice little addition we have as well. You can configure it in the GUI or via PowerShell in the registry. And it's actually quite easy to do. Basically what they do is they say, hey, create me a complete memory dump, but they add a filter key. And that filter key will filter out anything that does not have to do with the parent partition. So in a Hyper-V scenario, for example, this is very useful. And now we arrive at the place in the demo that having slides in it, which would be like kind of interesting. But let's continue. So that was the troubleshooting part. The troubleshooting part just says, hey, this is making your life easier when you're in trouble. But let's talk about the nice things. One of the really nice improvements, the ones we've been asking for and waiting for very, very long, is rolling cluster upgrades. Hey, we don't have to destroy a cluster anymore and create a new one. So life becomes a lot easier. And why did Microsoft do this? Well, they intend to release functionality and products a lot faster. It also ties into Azure, all the efforts in Azure. That moves along quite fast. So if you're going to do any type of hybrid IT, you want to keep these two in sync. Now, making people upgrade fast enough means two things. You're going to have to reduce the time they need to upgrade, and you have to reduce the risk. So take away the complexity, so that saves on time, and take away the risks, and basically that's what they've done. So what you can do now is you can take new hardware or your existing hardware, you put it out of the cluster, you take it out of the cluster, and you reinstall Windows Server 2016, you add it to the cluster. And that way you just replace each host in your cluster with a newly installed Windows Server 2016 machine. At that moment, while that process is running, you're in mixed mode, and then you have the backward compatibility mode. That means all your hosts are Windows Server 2016, but the functionality of your cluster is still at 2012 R2. Oh, hey. Look at that. Amazing.
Official support from E3.
VJ, dat is geen service.
Last it again.
You'll get an invoice.
We talked about this, we talked about the memory dump.
It's finished on my game.
Now you can do the registry, it's all very great. Now we're running cluster upgrades, and we're talking, well, reduce time, complexity, and risk. So what we were talking about is actually this one. We started with our 2012 R2 cluster. We are replacing the nodes with 2016. At a given moment, they are all 2016, but you're still running in the Windows Server 2012 mode. Once you're happy, satisfied, you don't have firmware issues, driver issues, you really want to make the switch, because at this moment you can still go back to 2012 R2. That's taking the risk away. It's no new cluster, that's taking the complexity away. But once you're happy, you can say, hey, upgrade that cluster functional level to 9, and then all the goodness that's new in clustering in 2016 comes alive. But it's even better. If this is a Hyper-V cluster, all your VMs are still at the configuration version for 2012 R2, level 5. That means that you can still move those virtual machines back to a 2012 R2 cluster or host. Something they didn't used to do. The moment you move them to a new version, the configuration version was updated automatically. So if you ran into a problem a week later, that was like, okay, how do you go back if you need to? Because there's a firmware bother issue. Well, you restore from backups, snapshots, whatever. But if that time is a bit long, you've got a big delta between the VMs you're restoring and the ones that you're running. And potentially you find out too late, and that's not really a plausible solution. So that takes away a lot of risk as well. Is it all hunky-dory? No, it's still not perfect. You will not be able to play that game with an older version of Windows than 2012 R2. You will need to make sure that you manage everything from the most recent edition of Windows. So add cluster nodes from 2016, manage them from 2016. That's not a big deal. One thing to watch out for is the storage capabilities in the two versions have changed dramatically for the better, which means that if you have any big plans to do a storage reorganization, do it either before or do it after you're done with the cluster upgrade, because otherwise you might run into issues. So that's not recommended. And also, of course, Microsoft wants you to move through the process reasonably fast. So don't stop halfway through and stay there for 6 months, because then again, why would you even bother upgrading? But it takes away the risk, it takes away the complexity, and that's what it's all about. One of my favorites is virtual machine compute resiliency. So, what is this doing? Well, basically, normally clustering is like a bodyguard. It sees a threat, it goes into alert mode, it shoots down everything that it thinks it's threatening the customer, and it evacuates the customer, which is great if it is a real serious threat. But what if you have this little transient failure? That's really overreacting. It's a shoot first and ask questions later policy. So what they're doing now is they're giving you the option of allowing the cluster to be a bit more considerate, have a bit more finesse in how it reacts. Situations that cause such transient errors might be a network glitch, cluster service crash, a node that gets disconnected either from the entire cluster or only partially. It only sees a couple of its member servers or not at all. So what it does now is it will put the node of the cluster in isolated mode, which basically states I can't detect or determine whether this cluster host is functional and hunky-dory, so it's isolated. You can't put any more workloads in there. It will not get VMs from a live migration. The VMs themselves, they go into an unmonitored state in the cluster GUI, and depending on what storage you're using, it's either paused or it's still running. When is it paused? When you're using block level. Why? If you have a cluster issue and a cluster using CSVs, no cluster, isolated mode, no CSVs, no storage. But it doesn't crash anymore, it goes into paused mode. It's not a crash and a failover, it waits a little bit. If it's SMB3, scale-out file server, it's external to the cluster. So hey, a virtual machine can run just fine without clustering. You just don't have the high availability. That's what they're doing. And of course, to deal with flapping issues, they have the quarantine mode. So if this happens over and over again, and this is tweakable, normally it's 3 times within an hour, even if the service comes back up, the node will be quarantined for, by default, 2 hours. Gives you the time to fix it. Gives you also the possibility to say, hey, I fixed the issue. Now just rejoin this node to the cluster. But whatever happens, when it goes into quarantine mode, whether it's up and running or not, everything that can be live migrated will be live migrated. So it gives you the best possible option to make this all transparent to your customers, your end users. The business won't notice. They have a couple of parameters. I'll show during the demonstration how they work, but basically here you define all the thresholds. When does it happen? How long does it stay in which condition? They take it even further, and you've actually already seen it. Storage resiliency means that if you lose your storage, instead of crashing the VM, no, it goes into a pause state. Sorry. So in that pause state, there's no crash. Some applications can deal with a pause state. Stateless web servers, not a problem. If this is an Exchange DAG member, I'm pretty much guessing that the Exchange team will tell you, they're not going to support this. But for a lot of other workloads, this is better than crashing and failing over. So what they do is they pause the machine and they just go check, hey, is the storage back, is the storage back? If the storage comes back, they resume the virtual machine. By default, it does this for 30 minutes before it really fails over. And you can tweak that setting to be longer or shorter. And it becomes even better with SMB3 storage, because in that, with the guest clustering, because then you have the ability to, well, not only just detach your storage from the virtual machine, as the workload can fail over to another member of the guest cluster. So basically it says, hey, I lost my storage. It doesn't have to go into past critical. It just detaches its storage, and the workload fails over to one of the other members of the guest cluster. So it keeps working. And because this is a feature that might or might not work with the workload you're running, you configure it per VM. So this is not a cluster-wide setting or something. It's something you say, it's on by default, but you can turn it off based on the needs or the workload that's running in the VM. So that's the shared VSJ story. Another cool improvement, which I didn't have much problems with, but apparently a lot of customers did, and I got asked about it a lot, is for multi-channel to work in a cluster, you need multiple subnets. This is not a requirement of multi-channel. It has to do with clustering. Clustering until Windows Server 2016 sees only one NIC per subnet. So if you wanted to use multi-channel, you needed multiple subnets. Now, in some scenarios, it's expensive, hard, difficult, or even impossible to get extra subnets. If you work in a very standardized, structured environment, it might take many weeks, lots of complaints, firewall changing, network setups. So this was a barrier to adoption. And that adoption barrier became more and more important because we have CSV that uses multi-channel, or SMB direct. We have live migration, but now we also have storage spaces direct. The entire mechanism depends on it. You also now have storage replica, can also leverage multi-channel. Again, you see more and more hardware that is so capable that having an easy way to add bandwidth to your environment becomes more important. So that's an issue they've taken away. I suggest you just read it in the interest of time. Is it perfect? Yes, pretty much. There's only one thing you can do wrong, is that some people already said, oh cool, now we can throw in 4 or 2 NICs in there and we can do everything over the same NICs. That's not the use case for this feature. So you still have to design the networks for your cluster reasonably, but it makes things easier if you want to leverage multi-channel. Also very cool is node fairness. Node fairness basically means that the cluster will now look at the workload on the hosts, and if one of the hosts has a lot less workload than the other members of the cluster, it will redistribute the virtual machines for them, which is kind of cool. So if you have 2 nodes in a 6-node cluster that are doing nothing, the workload will be live migrated. And you can tweak the session. You can make it a bit more aggressive, and you can define the percentage of the workload. Now in TPV5, it was supposed to be this one. Move the high setting was move the host exceeds the average cluster load by 5%. Unfortunately, it's exactly the same as low and medium, but it's gone to 60%. So this little enhancement, which was still in the documentation when I made the slides, actually doesn't work, but it should work in RTM. So I had to decide, leave this one in or talk about the 60%. Well, this is where they're going for RTM. So that's the most aggressive setting. If you use Virtual Machine Manager with dynamic optimization, then just ignore the settings of the node fragments. But it's a nice little feature to have. Virtual machine start order. I don't know if many of you were confronted with the problem. Hey, when my host boots and my VMs come up, they'll come up in a random manner, and my Exchange complains my Active Directory is not available, or I have a storage or network appliance that's not up and running yet, but all the workloads are up there, they don't have connectivity. Well, they have virtual machine start order now. So you can determine the order in which they start, and you can also say what is considered to be up and running. So it's no longer the post message during boot, it's really saying, look, this service has to be running, and then it's considered to be up. Even better, you can group them into tiers. So you could say, hey, my database tier has to be up and running before I start my middle tier, and before I start my front-end web service.
The NICs in the Hyper-V, if I install it, will that random get Ethernet 1 to...
Well, yeah, you still have the concept of consistent device naming that deals with that. But you've had that since 2012. But depending on the firmware of your NIC vendor, that might work consistently or not. So even with some vendors, even if you put all the same NICs in the same slots in the server, you'll see that over 10 hosts, they are named differently. Anyway.
And that's still in?
It's really a firmware issue of the NIC vendor or the BIOS of the server. So these have to be bug-free, and then it will work consistently. But, warning be given here, there are many issues with BIOSes and firmware. So the idea is there, it's still there, it works actually very good, just not always with all vendors.
Okay.
Don't beat me up over that one. So, demo time. How are we doing on time, by the way? Because I'm not sure.
No, 5 people going so far.
Okay. I hope we're only at the half of the session. So, what you see?
I cannot believe this, but
Nothing.
Oh, come on.
If you need more time, just lock the door.
live demo.
Hey, we cannot change the topology. Duplicates. Yay, okay. So what you're seeing right here is the network. It's called, one of the networks is called same subnet multi-channel. And what you see here is, for the 3 nodes, they all have 2 NICs, and they're all in the same subnet. So now they show up in the GUI, the cluster validation wizard won't complain about them, and you can actually just leverage them without having to specify an extra subnet. This puts clustering and its behavior towards multi-channel on par with all the other workflows that use SMB. It finally behaves as defined by multi-channel itself, actually. So that's good news. And I just need to prove that this also works. So we have a perfmon here. So what we're going to do is live migrate some of these workloads. Let's go here. Let's make sure we live migrate the correct ones. These 3 VMs. Let's say live migration. And now it's multi-channel in action. The 2 NICs are being used, same subnet, nothing special to do. For a lot of people, this will make life a lot easier. So the other thing we thought was pretty cool to do was the virtual machine compute resiliency, and we'll try to demonstrate this. So let's kick off a little script. So let's take 2. So basically what we're going to do is we are going to mess with our cluster. So we have a healthy, happy cluster here, it's up and running. So what we'll do is we'll crash the server. It goes into isolated mode. You can see that the VMs are unmonitored. But actually, if you look in Hyper-V Manager, which we'll do later, is you'll see that they are still up and running because these are running on SMB3 storage, which is external to the Hyper-V cluster. So hey, it's joining again. It was a transient error. It's gone away. So we will be very bad in our behavior. We'll do that again. So there we go. We create just another issue. And the process repeats itself. But during the process, you should see that, where is my Hyper-V manager here? Thought I had opened it. Actually, you'll see them running during the entire process. Why? There's no need to crash them. So now we'll do that again. And of course now they'll keep running here. But in failover clustering, you'll see that we'll go into quarantine mode. Let me get rid of this one. Resolution isn't quarantined on this one. Where is he? Where is he? Where did he go?
You minimize it.
I can minimize it and I can't see it anymore on my screen, so let's go here. So, as you can see, it's quarantined. The issue's gone actually. That cluster node is actually fully functional, but what happened? They got live migrated away because it happened 3 times within 1 hour. And that's the thresholds you can configure and leverage to the best of your environment. Perhaps you want it to be more, perhaps you want it to be isolated less long. You can configure that to your heart's content and really tweak it to your environment. Of course, you shouldn't treat this that it stays up and running and isolated for 2 days because then you defeat the purpose. But for all the little transient errors, this is where you want to go.
You can do it per host.
It's per cluster. It's the cluster that does it.
if you have a remote one.
So you cannot say this host offers compute resiliency and it has to coordinate work and the VMs go, etc., etc. But it's a nice feature to have, and as more and more people are starting to use networking, SMB3, and as we all know, some people might have a little spanning tree issue going on for 10 seconds. This will save you, right? So that was the first demos.
But the VM, will that be killed or?
No. The VM will either pause if it's block level storage,
Yeah.
because in the cluster CSV is not available if the cluster role on that node is not available. So then they pause. But if it's SMB3, the storage is external to the cluster on which the virtual machines are running, so it's still available. So just like you can run a virtual machine on a standalone Hyper-V node, hey, they're running, so that your customer or your service will not suffer. In the paused scenario, of course it will, so SMB3 has the better story here. But still, they don't crash. So if you have a lot of web services and you have a transient issue of about 5 or 10 seconds, pausing and resuming a VM is a lot less, let's say, disruptive to your business than crashing all the VMs, failing them over to another node and rebooting them. Right? And if it's stateless VMs and you have a decently developed workload, they can manage it. But of course, not every workload will be able to handle such an event.
And if the storage disconnects, will it pause?
If the storage disconnects, then you have the situation where it will pause for 30 minutes. But you can tweak that. You can say, if my storage pauses for 10 minutes, I want it to fail over already. But that's tweakable. So, but normally in a scenario where you have SMB3, the compute resiliency is completely transparent. If it is the soft that goes away, the first minute you're still golden, because you have this persistent file handles in the SMB3 that will save you for the first 30 to 60 seconds. Afterwards, instead of crashing and failing over immediately, they will go into paused critical for 30 minutes, but you can tweak that. And you can turn it off as well. So really, these features are very cool, but you have to tweak them to your environment. And if you have to rely on this every day, every hour, you really have to start checking your infrastructure. Right? This is not like, let the cluster deal with it. No, you have an issue. Right?
But will you see it in VMM then?
Probably yes. Yeah. By RTM, that should be all okay, right? Come on, help me.
Yes.
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 Okay.
If in block mode,
Right.
in block mode, if a node cannot access the SAN,
The sound. Also,
Would it go through the directed mode, the storage?
yes, oh, this is actually one of the problems with demonstrating and testing it. Most of the time, you'll build your infrastructure redundant. So in a real life environment, demonstrating storage resiliency is actually hard. Because if you have two iSCSI HBAs or two FC HBAs to a SAN, okay, you lose one HBA, hey, no sweat, no problem. You lose two HBAs, CSV goes into redirected mode. You almost have to lose both HBAs or some other issue on the SAN. Yeah, so basically it's hard to show and to test unless you do it in a virtual machine. You can just disable the link. But more and more,
I think he was mentioning that usually you have to redirect mode of CSV access.
well, yeah, that's what I'm saying.
Over
As long as you have CSV in actions, you can still access it. So it's quite hard to demonstrate with block cloud, the storage resiliency. Yeah? But you can. And more people are, wise or not, designing their infrastructure to be lossy, right? It's all non-redundant, and they consider it a failure domain. If it's in the cloud, there's no dual HBAs, nothing. It's just compute nodes that can fail, and it's the infrastructure layer and the application layer that has to deal with the issue. In smaller environments, I still highly advise you to make it redundant. It's not that costly, it's not that huge a scale. And for CSV, this is a scenario that will shine more with SMB3, but it's nice to have. So you're covered in way more scenarios and incidents than ever before. And that's the cool thing about it. Now PowerPoint still thinks I'm in extended mode, so let's go back. Maybe somehow. Will it? Nope. Yes. Now. Yay. Okay. We're back. Okay. So, cloud witness. How did I get to cloud witness? Okay. Workgroup and multi-domain clusters. You can now build a cluster with workgroup nodes, and you can build a cluster across multiple Active Directory domains. Pretty cool. Why do they do this? Well, actually, the primary use case of this is SQL Server always on, and somebody's going to kill me for mentioning that name, but the availability groups. Why? They are tied to Active Directory. They are not, sorry, they are tied to Active Directory. And basically, Microsoft is depreciating SQL Server mirroring. So they're pushing, it's the last version of SQL Server 2016 that still has it, then it's gone. So they're pushing people away from the mirroring, but the mirroring is something you can do across domains. It's not tied into that Active Directory domain. So availability groups are the replacement, but they are dependent on Active Directory, so they have to get rid of that. And that's what this is doing. This is the primary use case. Of course, if you do this, you want to make sure your DNS is very, very good and healthy, because that's the only way you're ever going to get access to the workload of the cluster. Now, as I said, SQL Server is the target of this feature. For authentication, well, they've been telling you for 2 decades, use integrated authentication. In the era of the cloud, we are of course telling you not to do so, because then you might have issues. Can you use it for a file server or Hyper-V? Sure, but everything that is dependent on Kerberos is gone. So it's not the best experience or the most secure experience, so you might not want to do that. And then some workloads like message queuing, which needs Active Directory to store properties, it won't work at all. One of the the witness solutions for a domainless or workgroup cluster is a cloud witness. Because if you don't have a domain, or you have only workgroups, how can you do ACLIN on a file share witness? It won't work. So you either need a disk witness or something new, the cloud witness, which is pretty darn great actually. I've used this a lot of times now in the lab and it works just fine, it's easy to set up and it's cheap. If you use a file share, or if you can't use a file share, well, it's a good alternative. A file share, if you have a third data center, hey, you can do it. If you have connectivity, you have a highly available third data center, a file share is a good use case. What if you don't? What if you only have 2 sites? Well, this is where it comes in. It basically gives you the same functionality as a file share witness, but it's in Blob Storage in Azure. So if you didn't have a third site, what did people do? Did the file share on a PC somewhere in a branch office? Not very highly available, not a good choice. Or you could extend your AD to Azure, create a scale-out file server on VMs, put the file share on there, and use a VPN or an express route to use it as a file share for your cluster. That's complicated, it's expensive just to get to a file share. This is just a replacement. So it uses HTTP REST, which means, of course, that you will have to have port 443 open, either over the internet, a VPN, or Route Express. If that's impossible to you, well, then you have a problem. It won't work. That's what it looks like in Azure. So this is just a storage account of mine. You use Blob Storage. This is how you set it up in the PowerShell of the cluster. You can also do it in the GUI. You say, this is my account name, this is the access key, don't worry, it's a fake one. And basically that's it. What does it look like? Well, you got a file in the blob. The file is named after a grid. That grid is actually the same as the grid instance ID in the registry of a cluster. And if you have 100 clusters, that same little storage account can take hundreds or thousands of files. So it's extremely easy and fast to set up. It's extremely flexible. It has no drawbacks in comparison to a file share witness. The only issue you might run into, you need to have 443 open, internet, VPN, or Route Express. If you can't do that, you'll have to find another solution. Otherwise, I highly recommend you play with it. It's kind of fun and funny to see. The site awareness in Windows Server 2016 has been a godsend, I would say, because now your cluster and your nodes can be site aware. And they have changed the way they do it in TPV5. They now actually leverage something important, a fault domain. They have introduced fault domains in Windows, and one of the types of a fault domain for a cluster is of the type site. So you define 2 cities somewhere in Europe. One is primary, one is secondary, and then you just say, hey, these 2 nodes, that fault domain is city Bonn, and the other 2 are in Köln, right? That's what they do. And then all the behavior of that cluster then becomes tied into that site awareness. So if your VM is running in your primary site in Bonn, and something happens, a planned live migration, maintenance, a host crash, all the failovers will happen within that primary site. They will try to make sure that the primary site keeps humming along perfectly as good as possible. It favors the primary site, it knows about it, and it will only fail over to the other one in case that primary site goes really tits up. So, you can also say this preferred site, Bonn, this is Bonn, this is my preferred site, but it does something else than just help you with the placement of the cluster resources. It also will make sure that the quorum, if you have to dynamically adjust it, it will always favor that primary site, or that, perhaps better, preferred site. Once you set a site as preferred, it will do everything to keep that site up and running as long as possible, even at the cost of the other site. But there's more. The quorum split is a situation, if you have a multi-site cluster, where the clusters lose connectivity to the witness, and they lose connectivity amongst themselves. So the nodes can't talk to each other. So in that case, no witness, and you can't talk to all your nodes. So who's going to form the cluster? So they had this concept in 2012 R2, lower quorum priority node ID. You can never pronounce that thing when you need to. That was used to set the victims in such a scenario, which ones were not going to be used to form the cluster. Now they just take the preferred site. So when that situation happens, it knows, hey, my preferred site is in BOM, so whatever happens, I survive, the other one dies. So no split brain scenarios are possible, and instead of having to configure this per node, it's just a preferred site on the cluster that's used. It's a lot easier. You can also set your preferred site not at the cluster level, but also on group level. So that means in the case of virtual machines, you could have half of your virtual machines use site A as a preferred site, and the other half site B. And then they work in both directions. You just play failover site for each other. So you can have an active-active or multi-active data center. Failback, automatic failback is possible. That's not enabled by default. If you want to, you can tweak it to set the hours. Only fail back between 6 p.m. and 6 a.m. because then it's the least impact on my business. Is this something that you want? Probably not unless you really thought about it. So it's disabled by default, but you do have the ability. And if you really want to go for a fully automated and automatic failover and failback scenario, it's in there, but I would strongly suggest you all think about it and test it before you just switch it on and hope for the best. There's even this capability, possibility, it will be in RTM, I'm not sure, of site auto-configuration. So if you start in a greenfield scenario, you could actually say, hey, configure my sites based on the AD site, or if you don't have AD sites, on the subnets. And then it will automatically create the failover sites for you. Now, if you have designed all those things with only AD or subnets in mind and not this behavior, you might not want to do it, right? So only turn this on if this is all designed by default. Then you have new possibilities for hard reading. You already had same subnet, cross subnet, hard reading. Now, as you have multiple sites and the cluster is aware of it, you have cross-site heartbeats. And all these settings are configurable. What else do we have? Storage Replica. This is the first time in history, actually, with Microsoft, that you can now build that site, that multi-site cluster, which is site-aware with in-box tools. Because before, you always had to buy some vendor's capability to replicate the storage. Now it's in box. It's the first time you can build it A to Z, all with Microsoft technologies. Storage spaces direct. That's been talked about by I have 5 minutes. Can you
Yeah, the maximum latency was wondering, 35, 40 kilometers, what's maximum?
5 milliseconds. That's the default answer of every vendor. Something else is new, the health service. It actually has a built-in health service, and it can tell you, hey, is my replication running fine? Is my site okay? Is my storage spaces healthy? It can pinpoint, based on something else, the fault domains. Where is the problem? In what rack? In what JBOD? What disk is it? So the fault domains, where site, we've seen one in the site-aware clusters, with the fault domains, that's only one type of fault domain. So you also have site, rack, chassis, enclosure, and they both work together, health service, fault domains, to give you the best possible pinpointing and service about, is everything hunky-dory in my environment? Then there's distributed costs. Basically now within a cluster, you can define storage cost policies, both minimum and maximum, that are being enforced, and that are knowledgeable about the entire cluster. So it used to be what you had in 2012 R2, it was on the host. And it was only the maximum IOPS that was enforced, not the minimum. The minimum just logged an event and said, hey, I'm not making it. And if you were not looking for that event, nothing was happening. So now the policies are improved and it's across the cluster. Now it's still not aware of your storage array because you might be running Linux clusters or database servers against it. It's aware within the cluster of everything what's happening. It's not aware of what's happening outside of its scope. So that's perhaps still a drawback, but it's a vast improvement compared to what we had before. And maybe I can try to show you storage cost policies in the last seconds of this. Yep. So we have 2 virtual machines running here. This is one with, I think, 2 disks. Yeah. And then with some luck. Let's go to 3. What I'm doing here, there's no storage cross policies on this cluster. So now I'm going to create aggregated storage cross policy. Aggregated means the IOPS I define here, the minimum and the maximum, are shared between all the VMs, their disks that have this policy assigned. And then I create a dedicated one, and the dedicated one basically means if you get this policy assigned, you get the minimum and the maximum per disk in this policy. So let's demo this. I'm assigning the aggregated one now, and what's happening, I said maximum is 10,000. This VM has 2 disks, so it's about 2/3 of 10,000. It gets about 6,600 on average. Each disk gets 1/3 because there's 3 disks involved in the storage cost policy. This one has 2, so it gets 2/3 of the aggregated policy. Now, if you go ahead and stop. Yeah, you can stop. Well, basically, if you assign a dedicated policy, you would see it would be 20,000. Because the dedicated policy works per disk, per object assigned to the policy. 2 times 10,000 is 20,000. And that's it, because Claire told me to stop.